Hey everybody, welcome to your notes. We're doing section 3.6 today, which is compound inequalities. So please take out your notebook and get your notes started. Your essential question for today: what are the similarities between solving and graphing inequalities with the word and the word or? And what are the differences? So take a moment, pause if you need more time to write, but it's super important that you get all of this written down, and then we'll keep going. All right, first thought. You do not have to copy this whole problem into your notebook, but I just want you to think through it with me. You're planning the Snow Days dance. It will take 100 people to make the dance profitable, but the building safety code prohibits more than 300 occupants. So how do you write an inequality to model this situation? Well, here's what I'm going to do. I'm going to go through and highlight the numbers that I see. I see 100 and I see 300. And when I think about it, I'm like, hey, the 100 is probably the smallest. I always write the smallest on the left, and then the 300 is the biggest. And where would the x live? X in this case would live between them. Now, it will take 100 people to make the dance profitable. So that's the smallest side. Could it equal 100? The answer is yes. And then the 300 is the biggest. Could it equal 300? Yes. So there you go. That right there is a compound inequality. So we're going to be writing some of those today, and we're going to be solving some. It's going to be great. So goal number 1. Would you please write down the word compound inequality? So here it is. Compound inequality. What does that mean? Well, think about the word compound. And when you have a compound word, that means there's more than one. So a compound inequality consists of two inequalities connected with by and or. Gosh, that doesn't make sense. But connected by the words and or. And when you have and, your picture will look one way, and when you have or, it will look a different way. So here are two examples of each. Graph them and see the meaning of each one. So I would like you to write this in there. 0 is less than x, which is less than or equal to 4. Actually write that into your notebook. And we're going to graph it. Well, what would that look like? Well, I'm just going to draw a line out. So there's my line, incredibly straight. And because I see two numbers, I'm going to put those two numbers on there. So I'm going to put 0 here, 4 here. The smallest number is always to the left, bigger numbers to the right. Now I got to figure out, what do I circle? Well, I circle the 0, I circle the 4, and then I think, okay, the 0, do I fill that in? No. The 4, do I fill that in? Yes. Okay, and then where does x live? On the outside or on the inside? And x lives between. This is an and. Right here, it doesn't say that, but when your x lives in between, you just squiggle in between. That's an and. That's if I rewrote it with 2. 0 is less than x, and x is less than or equal to 4. Now try this one, and let's see what this one looks like. Again, I've got two numbers. I've got a -1 and I've got a 2. Open circle, close circle. I've got an open circle for both of them. Now I'm going to look, and it says x is less than -1. Well, which way is less than? This way is less than. So I fill in my arrow. I'm going out. X is greater than 2. That's this way. I'm going out. So when it was or, it looks different than and. Do you see the difference? We'll make that connection in a little while. All right, let's try this one. This one we actually have to solve. You've got -5 is less than or equal to 2x plus 3, and 2x plus 3 is less than 7. So let's see. I just put the line down. I don't worry about this less than or equal to sign until later. What do I undo first? If you want to unpause, if you just want to pause me and do it yourself, totally cool. I'm going to take away 3 from both sides. When I do that, did you get -8? Be really careful. Drop down my 2x. divided by 2, divided by 2. So negative 4 is less than or equal to x. Did I switch the sign or anything? No, because the 2 is positive. Now, over here, minus 3, I get, not 10, I get 4. That cancels out, drop my 2 down, 2x is less than 4, divide by 2, so x is less than 2. Alright, now I'm going to graph it. So the two numbers I see, negative 4 and 2, I put a circle in a circle, I close one of them in, which one? Exactly, the negative 4. Alright, now this says x is bigger. Be careful because the x is on the bigger than side. So it looks something like this. The x is bigger goes this way. The x is smaller than 2 goes this way. And it has to be both of them. So do you see where the squiggle part happens? Yep, I squiggle right in here because it's got to be both. Do you see how it makes the pink and the yellow make orange? That's where both of them happened. So negative 4 is less than x and x is less than 2. Let's try another one. Solve these. Show a graph of your solution. I would like you to write them down and solve both of them and push pause and then come on back in a minute. Alright, so I solved through and got x is less than 2 and x is greater than 3. Did you get those things? If not, check and see what did I do differently from you. Then I went over and graphed it, circled the 2, circled the 3. Now I've got to figure out x is less than 2. Well, x is less than 2 is this way, and x is this way. So have you noticed that or goes out? Or goes out and goes in. Good. Now the next one, you might have thought, I'm not exactly sure how to solve this. So here's what we're going to do. I drew a line at both. Did you see there was 2 inequalities? So I drew a line at both. Then I look in the middle and it says negative 1 minus 2x. So I'm going to undo the minus 1 by adding 1. And so usually what I would say is, okay, you have to do that on both sides of the line. So I'm going to add 1 over here. But do you see there's 2 lines? So I've got to do the same thing over here because there's 2 different things going on at the same time. So over here I get negative 2. In here I get 2x. What did I just miss? Yeah, don't forget to bring down that negative sign. And over here I've got 6. Alright, now I divide by negative 2, divide by negative 2, divide by negative 2. What happens when I divide by a negative? Yeah, I'm going to get 1 over here, negative 3 over here, but these signs are going to flip because of the negative on the negative 2. So there is my answer. 1 is greater than x, which is greater than negative 3. So I put a negative 3 here. I put a 1 here. Circle them both. Do I color either in? I do not. So I've got x is in between negative 3 and 1. Can it be negative 3? No, because it's not filled in. Alright, so that's solving. You're going to do several solving on your own. Then here, just a couple of extra things to think about. Write an inequality that describes each situation. Water is a non-liquid when the temperature is below 32 degrees Fahrenheit or is at least 212. So I'm going to put out, it says write an inequality. Well, here's kind of what happens just pictorially. It has to be below 32, so that's down here. Could it be 32? No, 32 is when it changes to water. And then at least 212, so could it be 212? Yeah, that's when it turns to steam. And then we go like this. So, but it said write an inequality. So when I do this, I see 32 is my smallest number. 212 is my biggest number. So I've got an or here because there's 2 different things that could happen. So x has to be smaller than 32, less than 32, or x has to be greater than or equal to 112. Why don't you try these two? Come back to me in a second. Alright, a refrigerator is designed to work on an electric line carrying from 115 volts to 120 volts. So I just write them both down. Is x going to live on the outside or the inside? Yep, x is between them. Could it equal 115? Yes, because it says from 115. So that's my small end. And that's my big end. Your arrows should always be facing in the same direction. If they're not, something went wrong. Last one. The park is 1.5 miles from your home and the mall is 2.25 miles from your home. What's the minimum distance between the park and the mall? Well, if I think about it, let's see. My house could be here and the mall could be here. Where else could the mall be? Could be on the other side. Good. Then the park. There are two places, like the minimum and the maximum the park could be. Do you see how the park is closer to your house? So could the park be here? You bet it could. But that's probably not where you thought of it. Where did you probably think? You probably thought of the park as over here with your house in the middle and the mall over here. That's what I would automatically think. But do you see how if the park comes first and then the mall, there's a different length between you, or between the park and the mall. If the park's between the two of you, or if you are between the two. So if the park was here and the mall was here, how far away would they be? I'm going to say 0.75 miles. Can you figure out why? And then what's the farthest they could be? 3.75. Do you see why? Check it out. See if you can figure that out. Then write an inequality. 0.75, 3.75. The D's in the middle. It could be exactly that. Could be exactly that. Or anywhere in between. So there's your lesson for today. You'll have some book work to do today or tomorrow. Write them down. Go back and watch if you need to. Go back through and review your notes. See what makes sense and what doesn't. I'll see you tomorrow.